Welcome to Hierarchical User Interface Component Architecture, in short HUICA, the topic of my dissertation in computer science. The dissertation itself has more or less a rather traditional table of content. For this presentation I will reorder the chapters a little bit and especially focus on the illustrative example of chapter 8 and especially the solution in chapter 6. As a quick orientation, where is this dissertation actually located? Well, it is directly in the heart of computer science and software engineering, and there in the software architecture discipline. So, hierarchical user interface component architecture, as the name implies, is a software architecture. It also touches the graphical user interface field of human-computer interaction, but as you will see later, it is actually really just touching this field because HUICA is actually more or less independent of the particular rendering of the view masks. In my doctoral, I really had the privilege to be able to work in 3 particular streams in parallel. First, the stream on the bottom is the scientific foundation stream, where actually all things like technical reports, conferences, master's thesis and the dissertation itself happened. The second stream was the technology stack of open source components like Component.js and later Gemstone.js and all particular small companion libraries and frameworks I created over the time. And the third stream was the practical experience stream in the industry. Here I actually created 14 applications together with coworkers, and the point of this doctoral was that once I got an interesting idea on the scientific side, I implemented them through the help of open source components, and these in turn helped to make particular experiences in applications in the industry. And vice versa, experiences in industry field triggered new features and other particular aspects in the open source component field, and this triggered sometimes the necessity of creating new concepts on the scientific foundation stream. As a consequence, there's a large and strong relationship between the HUICA as seen in the dissertation on one side and the various frameworks in the open source field on the other side. Especially the Gemstone.js technology stack tackles the whole HUICA scope, while Component.js and Component.js MVC tackle more or less the component orientation, the presentation model and data binding, and especially the model view controller component tree patterns. The companion GraphQL.io framework tackles the business model data binding. Just keeps these strong relationships in mind. Now let's jump directly into chapter 8, where an example application is shown. This application is named Units and Persons UNP. It can be thought of an application where an organizational chart is managed. It consists just of the 2 entities, unit and person, a few relationships between those 2 entities, and the use cases of creating, deleting and modifying units and person entities. In a classical specification, usually a mock-up like the one here on the right side will be drawn. The point of this application is that it provides maximum complexity in minimum use cases, and as such it is used as an illustrative example of the features of HUICA. When this application is implemented, the first step is a so-called user interface decomposition. This is not an unambiguous process because it's a highly creative act, and multiple variants exist how to decompose this particular interface. One variant you see here in the middle. And the essential point of HUICA is that it allows you to directly one-to-one map this decomposition on a logical side onto a component tree, which you see here on the bottom right. The essential point, as mentioned, is this direct mapping between the decomposition on the logical side and the component tree on the more or less physical side. Let's take the outer window or panel as the first example. We see it on the decomposition side, it's at the root of the tree. The same applies to the component tree, which has a triad of components, a controller, a model and a view, here named screen. Then we have a subtree consisting of a controller units, which directly corresponds to no pixels at all, because it just controls the delivery or provisioning of the unit's data, plus a model and a view named roster, which is a reusable widget, which have the corresponding pixels on the decomposition side of the UI. Then we have a subtree composed of a controller, model and view, so a whole triad for unit, which directly maps onto the dialog for a particular unit. And then the same which happens on the units exists for persons. There's first a controller named persons, which has no direct pixels on the UI side, which just controls the provisioning of persons into the presentation model of a particular widget, here once again named roster. So the interesting point is that the UI is not just decomposed into reusable or similar things. Those similar things are also implemented in a reusable way with the help of widgets inside the component tree. Finally, there's a person dialog, which has once again as the unit dialog a full triad corresponding to it. Once we implement the units and persons application, we get a particular user interface, here shown on the left side, plus a particular component tree here rendered through the component.js debugger view on the right side. On the bottom right, you see the particular amount of code which is necessary in JavaScript, CSS, HTML, JSON, YAML and INI for implementing this. It's about 1,767 lines of code, which is a very small application, but a lot larger than the usual Hello World. And this way can show you more details about HUICA. Now let's demo units and persons. First, tree states and state transitions. We now see the UNP on the left side and the component.js debugger on the right side. And the particular UI fragment here, the unit, directly corresponds to the component triad here on the right side. Now let's just query the state of the component unit, which is the controller component of this triad, and it is in state visible as we see. Now let's change this state to prepared, a lower state. What now happens is that the UI lost the rendering of this dialog because the components went down into the prepared, which is a lower state. We can reverse this and fire it up to bring it upwards to a visible state, a higher state, and you see the UI renders again the unit dialog because now the triad is completely up, here flagged by green bubbles and the visible state. Now let's tear down the screen view component. We see the whole UI is now unrendered from the browser DOM because every particular view component, which corresponds to particular pixels in the DOM, is now down in the prepared state. We can reverse this once again into the visible, and the whole UI renders again into the DOM tree. Second, the states invariants. Once again, let's look on this particular unit UI fragment. We have a corresponding triad here in the component tree. All are in state visible. Now let's tear down to a lower state the component unit, the controller, into prepared. You see once again the dialog or the UI fragment is gone. And the interesting point now is that the corresponding model and view components of this triad also have gone to prepared state. Once again, if I take others like the screen view down, the whole UI is gone. And you see not just the screen view itself, but all components below in the component tree are also now in prepared state. If I go up with the unit once again to visible, another interesting thing happens. Now not only the unit dialog appeared again, but also the outer unit and person panel, the screen. We just pushed up this particular controller component unit, but the invariants are enforced by the component system ensured that all parents also went up. HUICA is also about full independence and scalability during development time. For this, let us first just reduce the rendering size of the user interface and then duplicate the entire component tree. Now we have additional instances of all components in the tree. They are still in the created state, so we do not see the rendered UI of this instance. Now let's just fire up the states to the visible state and you see a second instance of the user interface appeared in the DOM. And they are actually completely different. We can interact with them completely independent of each other. Now another killer feature of HUICA, headless operation. Just have a look once again on this units sub-dialog. I can select individual units and in the detail dialog they occur for editing. If I now tear down this units dialog, the master, we still see the detail unit, but the master is now gone. But we can still interact with the whole UI by just manipulating the model component of the units triad. I here select programmatically individual items and you see in the detail dialog unit different entities are loaded for editing, even if, as the component tree shows, the master is down. Now even more about the presentation model and its data binding. We have this units dialog once again and the detail dialog unit. If we now programmatically address the unit model and fetch the data name, we see its example corporation and we can actually change it. Once we change it in the model, the UI directly reflects this. Or even vice versa, if I edit the UI in the DOM, it directly is reflected in the model in the component tree. Similar for other things like, for instance, the language. I can toggle the language, which is just a field inside a presentation model, and the whole UI reacts in multiple views on this presentation model field. We can even programmatically change this particular presentation model field. It's named GSlang. We can actually put German in or English and the UI reflects this. Now to the last feature, business model data binding. I've now opened Units in Person in two different browsers. On the left, we see the UNP running in Google Chrome. On the right, we see UNP running in Apple Safari, and below there is the log of the common server. If we now change a field on the right, we will see that immediately through the server, the field is updated in the left browser. If on this browser we select something and change it, it is directly reflected through the server on the right side. And similar on the right side, I can change a field and I immediately see it on the left side. On the left side, I can change or clear a field. It's directly reflected on the right side. I can even select a new field or field value here, and it's reflected. Similar on the left side. So in short, all fields are directly connected through a data binding through the server. So we have multiple instances of a UI running, and they are synchronized. See, left entry, right reflection of this. We can even on the right, for instance, manipulate the roster itself by deleting an entry. It's directly reflected on the left side. We can also delete on the left side. It's reflected on the right side. And we can even on the right side just add an entry. It's directly reflected on the left side. True data binding through the server. So this was chapter 8 of my dissertation, where the HUICA was showcased through the help of the Units and Persons application. I hope this example motivated you for HUICA.